Hello guys, welcome back to my YouTube channel. So today we are going to solve day 25 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 773, sliding puzzle. Okay, so in this problem we have given 2 into 3 board. There are 5 tiles labeled from 1 to 5 and an empty square represented by 0. A move consists of moving 0 and a 4 directionally adjacent number. Okay, the state of the board is solved if and only if board is 1 2 3 4 5 0. Okay, so in the end I want my board to be like this: 1 2 3 4 5 0. Okay, and let's say initially my board is like this: 1 2 3 4 0 5. Okay, initially. So what I can do here, so this is my 0. Okay, so I can swap these two, or I can swap these two. Okay, so we have to choose 0 and a 4 directionally adjacent number and swap it. Okay, so this is only possible. So let's say I swap this 0 and 5. Okay, so in the end this is what I'm going to achieve in my board, right? And this is my target: 1 2 3 4 5 0. Okay, so here I have to just return the number of moves that I'm doing. So here I just swap these 0 and 5, so this is just a single move, right? Okay, so we have given the puzzle board. We have to return the least number of moves required so that the state of the board is solved. If it is impossible for the state of the board to be solved, then in that case simply return -1. Okay, so now see this example. Okay, so I think this is the example I have covered, right? So here just one move. Okay, so this is nothing but 0, so I am going to swap these two. So here comes my 5 and here comes my 0. Okay, so 1 2 3 4 5 0. Okay, in the end, and that's what I want. So output is going to be 1. Okay, so now let's see the next example. Okay, so now this is interesting. Okay, so here my board is like this: 4 1 2 and 5 0 and 3. Okay, so here this is my 0. Okay, I can swap this 0 with 1, I can swap this 0 with 5, I can swap this 0 with 3. Okay, so total I have 3 choices here, right? 3 choices. So if I swap this 0, let's say I swap this 0 with 1. Okay, so then my board is going to look like this: 4 0 2 5 1 and 3. Okay, and let's say if I swap this 0 with 5, okay, then my board is going to look like this: 4 1 2 0 5 and 3. Okay, now let's say if I swap my 0 with 3. Okay, so then my board is going to look like this: 4 1 2 5 3 and 0. Okay, so here we have only 3 possibilities, right? I can swap this 0 with 1, I can swap this 0 with 5, I can swap this 0 with 3. Okay, 3 possibilities. So this is going to be my, let's say, level 1. Okay, in level 1 I have 3 total possibilities, right? I can swap 0 with 1, I can swap 0 with 5, I can swap with 0 with 3. Okay, this is my level 1. Okay, now next time, let's say let's say I'm checking for this one. Okay, I'm checking for this state. Okay, so here what are different possibilities? I can swap 0 with 4, or I can swap 0 with 5. Okay, now here if you see why I'm going to swap it with 0 with 5 again, I am moving back to this initial state now. So let's not do that, because here I have already completed level 1. Okay, it will only increase the path. It's like I am moving from point A to B. Okay, and then I am again moving back to A. So this is not what I want, right? So here what is the need of this? Okay, A to B 1 kilometer travel, then again B to A I travel 1 kilometer. So 2 kilometer is the best thing for me, or just stay here at A is the best thing for me, right? So just staying at A is the best thing here for me. So let's not check this. Okay, so in the later on in my code I'm going to keep track of the states that I have already visited. I'm not going to visit them again. Okay, so that's why I have explained this. Okay, so now here if I swap this 0 with 4, let's say 0 with 4. Okay, I swap like this. Okay, so here then what is the result? What is the new state that I'm going to get? I'm going to get something like this: 0 1 2 4 5 and 3. This is what I'm going to get. Okay, now here let's say this is my level 2. Okay, level 2. And same way here also I have different possibilities now. 0 I can swap with 4, 0 I can swap with 1. Okay, but it is going to move back to the initial state, so that's why, but we can move, right? 0 I can swap it with 3. Okay, so here I will get 3 different states, let's say. Okay, then here also I can swap this 0 with 3, which is going to move back to this initial state, so I'm not going to consider that. And 0 we can swap it with 2. Okay, 0 I can swap it with 2, so this is one state. Okay, so this is my level 2. Okay, so now here let's say I'm moving here only in this path only right now. Okay, but here also we are getting some states. Okay, so now here what I did, I can swap this 0 with 1 and I can swap this 0 with 4, but I have already visited this now, so let's not swap. Okay, so 0 with 1 I swap. Okay, so I will get something like this: 1 0 2 4 5 3. Okay, this is one state that I'm going to get. Okay, this is level 3. Okay, level 3, and here for these states also I'm going to get something in level 3. Okay, for these states also I'm going to get something in level 3. Now here let's say I swap 0 with 2. Okay, so I'm going to get something like this: 4 5 3. So this is what I'm going to get at level 4. Okay, let's say. Then here I swap this 0 with 3. Okay, so 1 2 3 0 4 5. This is what I'm going to get, and I'm getting this at level 5. Okay, so at level 5 I'm achieving this target. Okay, so this was the final target that we want to achieve, right? 1 2 3 4 5 0. 1 2 3 4 5 0. 1 2 3 4 5 0. Okay, this is what I want. So I get this answer at level 5. Okay, so level 1. Okay, so level 1, see these edges. Okay, a white color pencil. 1, then this is 2, this is 3, this is 4, and this is 5. Okay, so 5, total 5. Okay, 5 times 5 is the smallest number of moves that solves the board. Okay, so 5 is the number of moves. Okay, so 5 is nothing but the distance. Okay, distance, minimum distance we want area, right? So least number of moves simply means minimum distance. Okay, minimum distance is what I am referring here. Okay, so here level by level I'm checking, right? First this level, then second level, then third level, and wherever I achieve the target, okay, for the very first time, okay, at minimum time, okay, at minimum level, okay, that is going to be my result. So here what I'm talking about, I am talking about here BFS. Okay, simply means BFS. Okay, level by level of traversal, right? This is nothing but level of the traversal. Okay, from this level to this level, from this level to this level. Okay, states are continuously changing, right? So we have to find the minimum distance. Okay, and here these edges doesn't contain any weight. Okay, so don't think about any other algorithm. Okay, disastrous algorithm or something, algorithm. Okay, don't think about that. So here we are just dealing with this BFS traversal, right? So now uh, this is one thing, okay, that we are going to implement VFS here. Okay, this is the one thing. All right, now next thing that I want to show you here. Okay, so I hope that you guys are clear why we are implementing BFS here. Okay, so we are just going to find the minimum distance, okay, from this to the desired state. Okay, from source to our target. Okay, so now here from this state there are many possibilities, right? So from this state there are multiple possibilities. Okay, I can move here, I can move here, I can move here, right? Then from this state there are multiple possibilities. Okay, multiple possibilities. I get my result here. Okay, here there are multiple possibilities. From here there are multiple possibilities. I get some result here, but this is going to minimum distance, so I'm going to treat this as my final result. Okay, so this is there. Now here one more thing. uh, it's going to be a little bit tough, right? I'm getting multiple states, but using this 2D matrix, it is going to be a little bit tough. Okay, to maintain these metrics at all the levels. Okay, so can I do one thing here? This is my target. Can I write my target in the string builder form like this: 1 2 3 4 5 0. Okay, so this is going to be my target. Okay, so I can write it like this in string builder format. Okay, so to reduce a little bit complexity, right? So this is nothing but my target. 1 2 3 4 5 0. Okay, so 1 is at index 0, 2 is at index 1, 3 is at index 2, 4 is at index 3, 5 is at index 4, and 0 is at index 5. Okay, so now here this is what I know. Okay, this is my target. So here how I'm going to write this in my string builder form. I can write it like this: 4 1 2 5 0 3. Okay, 503. Okay, something like this. I can write it like this. Okay, ignore this. 412503. Right, I can write it like this. Okay, so now uh here okay, so here I want to show you one more thing here. Okay, 4 1 2. Okay, what is that? 412503. Okay, 503. Okay, so here if I give the indexing here 0 1 0 1 2. Okay, so this 0 is at position 1 by 1. Okay, and we can swap this with this position, right? We can swap this with this position, we can swap this position. Okay, so total three states. Okay, three different states. Okay, so first state, let's say I swap it with 0 with 1. Okay, so 4 0 2 5 1 3. Okay, and the next state, if I swap this 0 with 5, then 4 1 2 0 5 and 3. Okay, and the next state, let's say I swap this 0 with 3, then 4 1 2 and 5 3 0. Okay, so here I have to move from, if I write it in string builder form, 4 1 2 5 0 3 is my source, and I want to achieve my target as 1 2 3 4 5 0. Okay, this is what I want. Okay, this is going to my target, and this is my source, and this is my target. Okay, so here uh, okay, so here I can write this 402 513 like this. uh 402 513 like this, right? 402 513. Okay, here I can write this 412053 like this: 412053. Okay, and here I can write this 412530 here. 4, okay, 1 2 5 3 0. Okay, so all these states are in matrix form, and here I'm writing them in string builder form. Okay, and here now I want to show you one important thing. Okay, little bit complex. Okay, so here my 0 is at index. Okay, so here my 0, if you see in my string builder, my 0 is at index 0 1 2 3 4 5. Okay, so my 0 is at index 4. So when my 0 is at index 4, then I can swap this 0 with the element at index 1. Okay, when my 0 is at index 4, when my 0 is at index 4, I can swap it with this element, okay, at index 1. I can swap this 0 with this element at index 3. Okay, and I can swap this 0 with index 5. Okay, so these are the three things, right? Okay, so when my 0 is at index 4, okay, when my 0 is at index 4. Okay, so here let me write it like this: 0 at index 4, then I can swap this 0, okay, this 0 with the element which is at index 3, the element which is at index number 5, and the element which is at index 1. Okay, so that is why I am achieving all these things, right? Clear? Okay, so 4 4 1 3 5. Okay, so this is what I want to show. Okay, so now we know the states, okay, which are changing. So every time I have to swap the 0 only. Okay, 0 with that set elements. So here initially if my 0 is at index 4, Okay, then I can swap this 0 with element 5 which is at index 3. Then I can swap this 0 with element 3 which is at index 5. I can swap this 0 with element 1 which is at index 1. Okay, so this is for 4. Okay, so now after that, let's say okay, so this is for 4. Okay, if my 0 is at 4 index, then I can move to the these directions. Okay, so this is nothing but directions. Okay, so I have proved it visually. Okay, how this is happening. Okay, so now let's say my array is like this: 1 4 1 2, 0 here, 5 here, 3 here, something like this. Okay, let's say 4 1 2 3 5 0. Okay, so now you know that I can swap this 0 with this 5 or 0 with 2. Okay, two different things. Okay, so here I can write it like this: 4 1 0 3 5 2. Okay, this is the one case. Okay, and the next case is going to be 4 1 2 3 0 and 5. Okay, this is the next case. Okay, so now here how I'm going to write it in a string builder form. I'm going to write it like this: 4 1 2 3 5 0. Okay, so now here I am dealing with my this index. Okay, dealing with this index. So here if I just give the index, 0 index, 1 index, 2 index, 3 index, 4 index, 5 index. So here when my 0 is at 5 index, when my 0 is at my 5 index, then I can swap it with the elements. Okay, it with the elements at what indexes. This is what I need to write. So here if you see carefully, we are getting the two states. Okay, for this 4 1 2 3 5 0, we are getting this state 4 1 0 3 5 2, and we are getting this state 4 1 2 3 0 5, right? So here I'm swapping this 0 with the element 2 which is at 2 index. I can swap this 0 with element 5 which is at 4 index. So here we know the directions, right? If my 0 is at index 4, then I can move to 1. I can swap it with 1 3 and 5. If my 0 is at 5, I can swap it with 2 and 4. Okay, so this is a little bit tricky, right? But I know that you guys are clear now how we are writing the directions. Okay, so here I just want to prove the direction map. Okay, so here what is going to be my direction map for zeros possible moves in 1D representation of 2 into 3 board. So if my 0 is at index 0, then I can swap it with the elements at indexes 1 and 3. If my 0 is at index 1, then I can swap it with the elements which are at indexes 0 to 4. If my 0 is at index 2, okay, then I can swap it with the elements which are at index 1 and 5. If my 0 is at index 3, then I can swap it with the elements which are at index 0 and 4. When my 0 is at index 4, 0 at index 4, then I can swap it with the elements which are at index 1, 3 and 5. Okay, 1 3 and 5. Okay, so when my 0 is at index 5, I can swap it with the elements which are at index 2 and which are at index 4. Okay, which are at index 4. Okay, so I have proved this for this. You can try, you can take copy pen and pencil, okay, whatever you want, and try this. Okay, for this. So for 4 and 5 I have proved it here. Okay, when my 0 is at 5, then what are the directions I am moving. When my 0 is at index 4, then what are the directions I am moving. Okay, so this is important thing. So here what are the three things that are clear. Number one, we have to use BFS. Okay, because it is nothing but level order traversal, right? From this level to this level, from this state to this state. Okay, whatever you want to say, and minimum number of levels you want. Okay, this is one thing. Second thing, if we have already visited that particular state, we are not going to visit it again. Okay, so I have proved this with this thing. Okay, A to B and B to 1 or B to A. Okay, and the third thing, that we are going to use string builder and how we are getting these directions. Okay, so now we are just going to implement the same things that I've explained here, okay, in this 20 minutes video, whatever we have done right till now, right? So now I'm going to implement the same things in the code. Okay, so now let's move to the coding part. All right, so here first thing, let's create the direction map for zeros possible moves in a 1D representation of the 2 into 3 board. Okay, so create one array, 2D array, int directions is equal to new int. Okay, now at 0, okay, at 0 index, we can move to the elements which are at index 1 and 3. Okay, if my 0 is at 0 index, if my 0 is at 1 index, then I can swap with the elements which are at 0 index, 2 index, 4 index. If my 0 is at 2 index, then I can swap it with the elements which are at 1 and 5 index. Okay, so same thing whatever I explained here, right? 0 1 3 1 0 2 4 2 1 5. Okay, so I'm going to try the same thing here, right? 0 comma 4, and then what we have here, 1 3 5 and 2 4. Okay, 1 3 5. Okay, and then we have 2 comma 4. Okay, this is done. So if you are solving this question for very first time, then definitely these things will not come to your mind. Okay, so definitely this is hard. Okay, I'm not going to say that this problem is a medium level or easy level. Okay, this problem is definitely hard if you are solving it very first time. Okay, so it's all right, right? No issues if you are not able to solve this problem. Okay, so now, but if you are trying to solve it, then it's good. So now my target is going to be string builder. Okay, so this thing also should not come to your mind, okay, for the very first time if you are solving it. Okay, this thing will definitely not come to your mind if you are solving it for first time. This thing will definitely not come to your mind if you are solving it for very first time. Okay, so yes, so don't worry. Okay, now after that, create string builder start state. Okay, so start state, so I'm going to fill all the values, okay, in the start whatever we have, right? So here in the start we have 412503. Okay, so this is what I'm going to fill. New string builder. Now we have to convert the 2D board into a string representation. Okay, so for int I is equal to 0, I is less than board dot length, you know, number of rows we have 2. Okay, and I plus plus, and the number of columns we have is 3, right? So for int j is equal to 0, j is less than 3, j plus plus, and then after that, uh, in my start state, okay, I have to fill the values. So start state dot append the element board element at the particular index, okay, I and j. All right, so this is clear. Okay, we have 2 into 3 board. Okay, so we can simply write here 2 and 3, no issues. All right, done. Then after that, we have to keep track of the wasted states, because we don't want, if I move from A to B, then I come back to A. That is not good, right? That doesn't make any sense. Okay, so create one set string visited is equal to new hash set. Okay, to store the wasted states. Then after that, create a queue. We are using BFS, definitely I'm going to use queue. Okay, in queue I'm just going to add the first state, okay, and which is in string format. String queue is equal to new linked list. All right, now first thing in my queue, just add the first state. Okay, q dot add start state dot and convert it to string. In q I am passing strings only. All right, this is done. Okay, and we are at first state, so let's mark it as visited as well. Okay, so till now I hope that you guys don't have any issues, right? Visited dot add start state dot to string. Clear until now, right? Okay, now after that we are counting the moves only, level by level, how many levels we are visiting. Okay, so initially moves is 0. I am at this position right now, moves is 0. Okay, after that here my moves will be 1, here my moves will be 2, here my moves will be 3. Okay, level by level. Okay, now we are just going to write the BFS code, BFS, to find the minimum number of moves. So while my queue is not empty, this is the standard code for queue, right? While my queue is not empty. Okay, so what is the size of queue? Take the size of queue dot size. Okay, and now while size, okay, then we have to decrement it later on, and it should always be greater than 0. Okay, so if this is satisfied, okay, if my size is greater than 0, and then we decrement the size. Okay, so here current state, so string current state is equal to q dot poll. Okay, this is done. So this is my current state. Okay, initially 4 1 2 5 0 3. Okay, I poll this. Okay, I poll this out. Okay, so this is done. Now for this we have to check, okay, from here, if we reach the target solve state. Okay, initially let's say it is like this only, initially it is like this only, 1 2 3 4 5 0. Okay, initially only, then we have to stop there. We just simply return moves. Okay, so that's what I'm checking, one base condition. So here, if current state dot equals, okay, a target, okay, if this is equal to my target, then simply return moves. Okay, so this is one base condition. So until now I know that you guys are clear, right? So now after that, first, okay, now we have to find the position of 0 in the starting. So position of 0 is at index 4. Okay, position or index 4. Okay, so from 4 we can move to, if my 0 is at 4, so we can check in 1 3 and 5, we can swap in 1 3 5. Okay, so this is, but so here 0 position, first find what is my 0 position, then we have to swap. Okay, finding the different states, because states are every time changing, right? So 0 position is equal to current state dot index of 0. Okay, this is what I'm trying to find. Okay, so this is going to give me the 0 position. Okay, all right, right. Now after that, what we are going to do, for, okay, I'm running one for each loop for int new positions. Okay, new position. Okay, zeros new position. Okay, so new position. So what are different new positions? So we have stored the directions now. If my 0 is at index 4, then these are the different new positions, okay, of 0 1 3 5, right? These are the new positions. Okay, so here what I'm going to write on directions. Okay, in directions index I'm going to pass my 0 position. Okay, 0 position, this is going to my index. Okay, so now here inside this string next state, so string next state, string next state. Okay, and how I'm going to get the next state? Okay, so here 412503, so next state is going to be 402513, 412053, 412530. Okay, these are different next states. Okay, so I'm swapping. Okay, so here I'm going to call one method swap. Okay, I'm going to later define it swap. So in this swap, I'm just pass just my current state. Okay, and just pass my 0 position, okay, because I'm swapping current state 0 position, okay, index with the new position index, okay. So all these new position index one by one, okay, new position, okay. So I'm expecting this next state to give me the next state, okay. So here let me just write new position, okay. So this is done, okay, this is done. Now here if we have to skip if this state has been visited already, okay. So if so this is one basic check we have to do. If visited dot contains if visited dot contains next state, okay, then in that case simply continue na? Don't do anything, continue. All right, and okay, and after that we have to mark the new state as visited and add it to the queue, okay. So visited dot add next state and in the queue dot add next state, okay. This is done, okay. And here my this while loop ends, okay, until my if my size becomes 0, okay, at any position. All right, then we have to simply do one thing, okay. And every time there is one more thing. So here we have to increment the moves every time, okay, moves plus plus, okay. So if we cover this complete state, then my moves will be incremented, okay, if I move into the next state, okay. So moves plus plus every time, okay. This is one thing, right. And here this ends, okay. And after that simply return -1 if we don't execute this step anywhere, okay. So simply return -1 here, return -1, okay. This is done. Now that's it, okay. So now here let's write the helper method to swap characters at indices I and j in the string, okay. So it is very simple, okay, it will not take time. Our main code is completed, okay. So no, so that's it. So here just write this swap, so this will not take much time. String, what we are doing, return type is going to be string only, and I'm just going to write the code for swap. So in this step what we are passing the current string, okay. So you can write string str, and we are passing indices, okay, int I int j. All right, and now create one string builder. Sb is equal to new string builder, okay. And here just pass str current string that I have, and now sb dot character at index I, okay. So let's just set now. So here's sb dot, you can use set character at index I, okay. Here string dot char at index j, okay. We are just swapping now, okay. Sb dot set char at index I with the string dot character at j, okay. And sb dot set char at index j with the string dot character at index I. And once this is done, then we have to just return the new set, okay, new string, okay, new sb dot to string, return type is string, okay. That's it. So now let's run the code and see if there are any code issues. So yes, okay. So here it should be I now, okay. So now let's run it again. So the test cases has been accepted, okay. And the time complexity, so here we are running just for 6 times, okay. So 6 times we are running here, okay. 2 into 3 6, and we are filling the board, okay. Then after that here I am, okay. So here you can simply say, right, uh, how many total positions are there, okay. Total positions are 6, okay. Total positions are 6, right. And if okay, total positions are 6, we have given 2 into 3 matrix. Okay, I'm talking about time complexity, 2 into 3 matrix. Okay, so total positions are 6. All right, and here I can have 0 here, I can have 1 here, I can have 2 here, I can have 3 here, I can have 4 here, I can have 5 here. Okay, so total 6 values I have here. Okay, so total 6 values I can fill. I have choices. Okay, different states. How many total number of states I'm talking about here? Okay, so 6. So if I use any one value here, then at this position I can only use 5. Okay, if I use, let's say, 0 here, then I'm only left with these 5. Okay, if I use, let's say, 1 here, then I'm only left with 4. Okay, so total position 6. Okay, and at first position I am filling 6, and next position I am filling 5, and at next position I am filling 4. Okay, so this is nothing but 6 factorial. Okay, 6 factorial total choices here, right, for each cell. Okay, so total time complexity, I'm going to say that 6 into 6 factorial. Okay, or you can simply say 6 factorial. Okay, since 6 size is very large or very small. Okay, so 6 factorial you can say, or if you write it in m into n format, so you can say m into n, and here dot m into n factorial. Okay, right, so now let's submit it. So see, our solution is accepted. I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.